Here is the problem. We are given a block diagram with three gain blocks, K1, K2, and K3, plus a disturbance input D. The signal U is the input and Y is the output. Let me describe the diagram. The input U enters a summing junction with negative feedback. From there, the signal goes through an integrator, 1 over S. The output of this integrator feeds back through the gain, K1, to the first summing junction. That is a negative feedback loop. After the integrator, the signal reaches a second summing junction. The disturbance D enters this junction through its own separate integrator, 1 over S. From the second summing junction, the signal splits into two parallel paths. The upper path goes through K2 directly. The lower path goes through K3 and then through another integrator, 1 over S. The two paths recombine at a final summing junction to produce the output Y. Our task: simplify this into the form U, G1, summing junction with D, G2, Y. We need to find G1 of S and G2 of S explicitly. Before we start simplifying, let us quickly recall the three block diagram rules we will use. Rule 1. Series connection. Two blocks in a row multiply. G1 followed by G2 gives G1 times G2. Rule 2. Parallel connection. Two blocks sharing the same input and their outputs are added give G1 plus G2. Rule 3. Negative feedback loop. A forward path G with feedback H gives G over 1 plus G times H. These three rules are all we need. Let us apply them step by step. Step 1. Resolve the feedback loop. Look at the left side of the diagram. The forward path is an integrator, 1 over S. The feedback path is the gain K1. Using the feedback rule, the closed-loop transfer function is the forward path divided by 1 plus forward times feedback. That gives us 1 over S divided by 1 plus 1 over S times K1. Simplify the denominator. 1 plus K1 over S equals S plus K1 all over S. So the fraction becomes 1 over S divided by S plus K1 over S. The S in the numerator and denominator cancel, and we get 1 over S plus K1. After this step, the feedback loop is replaced by a single block, 1 over the quantity S plus K1. Step 2. Combine the parallel paths. After the second summing junction, we have two paths in parallel. The upper path is K2 by itself. The lower path is K3, followed by an integrator 1 over S. Using the series rule, K3 times 1 over S gives K3 over S. Now, using the parallel rule, the combined block is K2 plus K3 over S. To write this as a single fraction, K2 times S over S plus K3 over S equals K2S plus K3, all over S. So the two parallel paths become one block, K2S plus K3 divided by S. Step 3. Rearrange to match the target form. Right now, our diagram looks like this. U goes through 1 over S plus K1, then reaches a summing junction where D enters through an integrator 1 over S. And then the combined signal goes through K2S plus K3 over S to produce Y. But the target form requires D to enter the summing junction directly without any integrator. So we need to move that 1 over S block. Here is the trick. If we remove 1 over S from D's path, we must compensate. We multiply the path before the junction by S, which is the inverse of 1 over S. And we multiply the path after the junction by 1 over S. Before the junction, 1 over S plus K1 times S equals S over S plus K1. After the junction, K2S plus K3 over S times 1 over S equals K2S plus K3 over S squared. Now D enters the junction directly, and we have our target form. Here is the final answer. G1 of S equals S divided by S plus K1. G2 of S equals K2S plus K3 divided by S squared. Let us verify this makes sense. For the input U, the signal goes through G1, then G2. G1 times G2 equals S over S plus K1 times K2S plus K3 over S squared. That gives K2S plus K3 over S squared times S plus K1. This should match the original path from U to Y through all the blocks, and it does. For the disturbance D, it enters the junction directly, then goes through G2. So the disturbance transfer function is G2 equals K2S plus K3 over S squared. Both check out. Let us recap. We started with a block diagram containing 3 gains, K1, K2, K3, 3 integrators, and a disturbance input D. In 3 steps, we simplified it. Step 1. We closed the K1 feedback loop to get 1 over S plus K1. Step 2. We combined the K2 and K3 parallel paths to get K2S plus K3 over S. Step 3. We moved the disturbance integrator by multiplying the forward path by S and the planned path by 1 over S. Final result. G1 of S equals S over S plus K1. G2 of S equals K2S plus K3 over S squared. 3 rules, 3 steps, done.